Okay, we'll proceed to our next presentation. Shelby Corray from dsm-firmenich will talk about looking to improve opportunities to improve breast meat yield. 25-hydroxy-D3 may be an answer. Shelby, welcome and great to have you.
Thanks, Sam, and thanks everybody. Glad to be here. Today I'm going to talk about 25-hydroxy-D3 and the importance of it, and then the effect that it has on muscle development in broilers. So first, we'll kind of go over the structure of vitamin D, the chemical structure, and some of the metabolite forms so we can understand a bit better as we go forward. So vitamin D, a fat-soluble vitamin, and we know vitamin D2, naturally occurring in fungi and yeast, is less potent than D3. Only about 10% is absorbed compared to D3 in birds. That vitamin D3 that we talk about that's in the diets, naturally occurring in humans and animals, we get it from diet, the sun. It's a precursor to that storage form, which is the 25-hydroxy-D3. And then the biologically active form is the 1,25-dihydroxy. And today we're going to focus on the metabolite, specifically on 25-hydroxy-D3, which is that circulating form. And you can see its chemical structure here. It has the hydroxy on the 25 marker. So what are some of the functions, or how does it get to the bird and to the different tissues? So through the diet, through supplementation of vitamin D3, it goes through the intestine to be absorbed, and then it is transported into the liver to be hydroxylated, and that's when we get our 25-hydroxy-D3. That step is then through the kidneys, and in the kidneys, it's hydroxylated again to become that 125, or that active hormonal form that we talk about. And then from there, it'll go to the target tissues. And that could be anywhere from intestines, bone, muscle, the immune system, and of course the kidney. And when we're looking at the kidney and when we have got the 25-hydroxy-D3 present in that tissue, this is really that endocrine pathway and where we see the calcium phosphorus homeostasis and that bone metabolism that we so often think about when we think about vitamin D3. And then in the other target tissues where we see that 25-hydroxy-D3 be active, we have our vitamin D receptors in the intestine, the bone, the muscle, all of these listed below here as the target tissues. And that's another location where those 25-hydroxy-D3 metabolites are finding their way and having an effect. And so to look at it a little bit differently, we think about birds being raised inside, and we think about vitamin D3 typically coming from the sun, but that's not the case for our livestock raised inside. And so again, there's a very low conversion rate for birds, and being raised indoors, they're not getting it through there. So we know we have to supply it through the diet. When vitamin D3 is supplied through the diet, it goes through the gut and is absorbed into the gut. And from there, it can go into the liver. That gut absorption, though, is dependent upon lipase and bile acids. And in those young birds, or if a bird has an enteric disorder, the absorption could be limited in this step. Again, there it goes to the liver to be hydroxylated into 25-hydroxy-D3. And this is done by 25-hydroxylase enzyme, which is nonspecific and it's a non-regulated enzyme. And this is where we get that circulating form of 25-hydroxy-D3 that we test for when we pull blood. From there, it's moved and hydroxylated again into the kidney. And this is when we get that 125, which is the active form. This production process is very carefully regulated. So some of the limitations of feeding a dietary vitamin D3 are if there are any gut challenges in those birds, it can compromise the absorption of D3. And early on, lipase and 25-hydroxylase enzymes are not sufficient in those young birds. Any liver challenge that they may be going through could also compromise the hydroxylation of D3 into 25-hydroxy. So ultimately, this is going to lead to lower circulating levels of this active form if we're only feeding vitamin D3 and not feeding a supplemental 25-hydroxy. So why 25-hydroxy? And like I just sort of touched on and explained, 25-hydroxy-D3 is going to give you more faster, efficient absorption compared to feeding a vitamin D3 alone. There's increased water solubility due to it already being hydroxylated and in that 25-OH-D3 form. We can skip that conversion step in the liver. So if there's any sort of enteric challenges like enteritis, malabsorption, any effect like that, we can bypass those issues, and you're still going to get the 25-hydroxy-D3 into the serum like you need it to be. it can be absorbed in the gut, straight to the kidney, and then to the other target tissues. So you know you're going to get those levels that the bird requires. Absorption is less affected by gut status. So if there's enzymatic insufficiencies, fat metabolism, enteric challenges, and then you're going to make sure you get those higher serum levels. Actually increasing your D3 can downregulate that hydroxylase enzyme. And so you're not going to get that 25-hydroxy that you need. So increasing D3 is not necessarily going to get you the serum levels that you need. And so we think about the physiology, and I've mentioned that early on birds have insufficient levels of some of these enzymes to be able to help that D3 be absorbed. What's been shown is that trypsin, amylase, and lipase all are pretty low here from day 0 until about day 12 to 14. We can see that here in all 3 of these graphs with lipase and bile acid as well. It isn't until a little closer to day 14 to 21 is when it really starts to bump up production of those enzymes to be able to help with absorption. So early on, those first couple of weeks, lower enzyme production, lower absorption of those fat-soluble vitamins. And so when you have lower absorption, you're going to have lower conversion of D3 to the 25-hydroxy D3, and therefore lower circulating levels in your plasma. And we can see that here in this graph when we're looking at plasma of 25-hydroxy. It stays pretty low, even dips down a bit day 10. And then you can see around day 14, it really starts to increase as those enzymes increase and D3 can be absorbed more efficiently in the gut. So those other physiological factors that could play a role in how vitamin D3 is absorbed and transferred into 25-hydroxy is any sort of metabolic issues that may be going on, maybe in older birds. If we're talking layers here, if we're talking breeders with fatty liver, stress from heat or management can impact vitamin D. Liver damage, whether toxic or bacterial, can also affect the absorption and digestion of fat-soluble vitamins. And so when we're looking at 25-hydroxy D3 being fed directly into the diet versus vitamin D3, we can kind of graph out and see what we've seen in many research studies and has been well determined. And if you look at the red line here, we can see vitamin D3, even as you increase those D3 levels, so we're increasing them here, we're not getting an increased level in the blood. Same as for the graph on the right, as we increase that vitamin D3, we're not seeing any sort of increase in the intestine either. When we look at 25-hydroxy D3 being fed in the diet, we can see that gradual linear increase as we increase the 25-hydroxy D3 that's fed. So that has a direct impact on the plasma and on the intestine as well. And so at the bottom, now we're looking at our 25-hydroxy D3 is that orange bar here, and that double D. So this is looking at vitamin D3. If we just doubled it, this is around 5,000 IUs. We get a slight increase compared to that lower level of vitamin D3 at about 2,700 IUs, but still you're not getting to that 25-hydroxy level just simply because D3 is not going to equate to the same as feeding 25-hydroxy directly in the diet. The graph on the right here is showing the similar thing. And what we wanted to show with this trial is that 25-hydroxy has a half-life of around 15 days. And so it's one of those things you have to keep in your diets to keep those serum levels high up there. So in that light green bar, you can see our 25-hydroxy that was fed until 42 days of age. The plasma levels stay well above that of vitamin D or after removal of 25-hydroxy. So again, just showing the importance and showing kind of that half-life, but additional supply of vitamin D3 does not necessarily generate the same results as supplying 25-hydroxy D3 to the diet. And we can see the difference in those levels. And again, that half-life of about 14 days. So once removed, 25-hydroxy starts to decrease in the plasma. So what does that mean? What are the main functions of 25-hydroxy? Why is it so important? What are the biological actions it can have on the bird? And we generally think about mineral homeostasis and bone metabolism, but there are also several other important biological actions that 25-hydroxy has on the bird, and that includes immune function, fertility, and then today we're going to focus next on skeletal muscle development and growth. And so how is the muscle growing? We know that the number of muscle fibers that a chick has or a broiler has are defined at hatch. It's the same in humans at birth. in all species. As you are hatched or born, the muscle fibers that you have, that is all you're going to have. After hatch, however, the muscle size can grow. So when we talk about muscle growth, we're talking about growing in size, not in number. And there's satellite cells located around these muscle fibers, and this is what enables that muscle to grow in size. So we see here what that kind of looks like. So when 25-hydroxy-D3 is added into the diet in either the breeder or the broiler diet, both have been proven, we can see an increase in satellite cells, an increase in myonucleus, more myogenic factors, and then therefore all of which are increasing the protein synthesis and leading to more meat. And so what do we know specifically about the role 25-hydroxy plays, and what are the mechanisms behind this? And so in broilers, we see that effect on satellite cells and protein synthesis. It's been demonstrated that 25-hydroxy-D3 can improve the production of the vitamin D receptors, which are really important. And I mentioned before, those are in all of those target tissues, including muscles. Myogenic regulator factors are also improved or increased, such as MyoD. We've seen increases in the number and activity of satellite cells. So again, right there present on the muscle fiber that are important for muscle growth. Therefore, we've seen an increase in protein synthesis and breast meat content. And so 25-hydroxy is really stimulating that muscle development through those satellite cells to enhance that protein synthesis and therefore generate more muscle instead of depositing lipid, and we're getting more meat. And so we can look specifically at some of these trials to see what were the numbers and what does 25-hydroxy do. So 25-hydroxy-D3 was shown to significantly improve the myogenic factors. So we see Myo5, Pac7, and MyoD all are involved in muscle differentiation, transcription of the satellite cells, and regeneration of tissue. And we can see that when 25-hydroxy was added here in the green bar, significantly increased from our control level of D, or even a higher level of D here, which was shown in the OBN. Looking now at the vitamin D receptor, again, important to have the activation of vitamin D receptors, because without that, you're not going to have the action of 25-hydroxy-D3. And we could see that feeding that actually improves the activation of those receptors. So that's great to see, because now you're going to have more activity within those cells. So looking further at the satellite cells, this particular trial looks at several days, and I just wanted to pull a few for sake of time. But on day 14, we could see that the Myo5 satellite cell density was had a tendency to be higher than the D3 alone. Pretty large jump in number there. If we look at the Pac7 satellite cells, so again involved in differentiation and protein synthesis, we saw a significant improvement with 25-hydroxy-D3 treatments. It also led to greater density in a larger muscle fiber area of the pectoralis major. Looking at the nuclear density and the muscle fiber cross-sectional, we can see a significant improvement with 25-hydroxy versus feeding dietary D3 alone. So a few other factors involved in protein synthesis would be our IGF-1 and looking at our protein synthesis rate specifically. And here in this trial, we had control level of D3, which was around 2,700 IUs of D3. We had our high level of D, which was doubling that at 5,500 IUs. So again, you can see what we kind of talked about earlier. Just because we doubled the vitamin D3 did not mean we're seeing double the effect or even the same as a 25-hydroxy. So our 25-hydroxy-D3 added throughout the entire 42 days had the largest impact on IGF-1 expression, which is directly involved in protein synthesis. And then if we looked at protein synthesis at that fractional synthesis rate, we can see that significant increase in 25-hydroxy diet. A couple other indicators that we looked at in this trial were mTOR and S6K1. mTOR is a protein kinase. It regulates all kinds of things in the cell involved with growth, proliferation, motility, survival, protein synthesis, and transcription of some of those factors that I mentioned earlier. So we were able to see that 25-hydroxy-D3 significantly improved the mTOR gene expression. So able to, again, help another factor helping with protein synthesis rate in those 25-hydroxy-D3 treatments, as well as the S6K1 gene expression, another one of those gene markers involved in protein synthesis. So we're seeing it throughout these transcription factors. And in this trial, to show the breast meat yield improvement and how it relates to a practical sense, we look at all these cellular level. At a practical level, we saw an significant increase in breast meat yield improvement. May not seem like a lot from 19.7 to 20.4, but when we're looking at breast meat yield and talking about percentage, and when producers are paid on that, that is a pretty significant increase. And so we've looked at this breast meat yield percent improvement over several field trials, research trials, both small and large, and then some industry data that we've gathered as well. And overall, between all of these trials to date, we have a few more to add here, but there's some breast meat yield improvement of 0.75% on average in the US. If we look across the globe to see, what's happening globally in the EU and North America, we can see an average improvement of about 1% in breast meat yield. And we continue to collect this data to see what we're seeing. And it's a range anywhere between 0.3%, upwards of almost 4% that we've seen in a couple of trials. And so to break down some of the US industry data, just to show one of the pieces that we've peeled out. In 2018, we collected this on small birds looking at 3.6 to about 4.4 pounds. Again, just selected the small birds for sake of time. And if we look at no 25-hydroxy-D3 and we look at 25-hydroxy-D3 fed in the starter only and 25-hydroxy-D3 fed beyond the starter, so this could mean starter grower or starter grower finisher, and we can look at the differences here. We see a WOG yield of an improvement of 0.7% or 1.1%. If we look at breast meat yield improvement, we can see that 0.6% or even up to 1% if 25-hydroxy was fed throughout the life cycle of that bird. So in the industry data, we're seeing this as well as our research setting. So overall, 25-hydroxy-D3 is improving that breast meat yield by stimulating muscle development through the satellite cells, those myogenic factors, and increasing that protein synthesis rate, leading to more muscle and therefore that higher meat yield. With that, I can take any questions. Thank you.
Great job, Shelby. Really nice presentation and great data. It tells a good story on how you've got the molecular mechanisms all the way through very applied field trials data that you've collected from the field. I know there's been some work on this. How about meat quality? Obviously, you're getting improvements in breast meat yield. Do you see any changes in meat quality one way or the other?
Yeah, that's a great question. And we do have some of that information. For sake of time, I wasn't able to include much of it, but I can say that we've run a few trials to see the protein content and how that's increased. And we've been able to pick that up in 3 different trials, one of those being a customer trial. So there are some differences even in content of that breast meat. Mm-hmm.
Yeah, makes sense. And certainly it makes sense. I mean, you touched on the fact that from the enteric infections, I've seen in work that we've done here, any minor damage, particularly due to Eimeria to the intestine, lipid digestibility and utilization is disproportionately impacted compared with the other nutrients. So, and there's, been literature to show that has a direct impact on vitamin D and obviously and subsequent effects that we'd see there. So yeah, I think that's a very strong case.
Yeah, that's right. Yeah. And early on in those birds, it's really beneficial that we have the ability to feed 25-hydroxy-D3 and not rely on vitamin D3 for those reasons, because the birds are stressed. It's harder to get that to their blood. So
sure. You talked a lot about broilers and how that translates in breast meat yield. What about in layers? What type of recent updates on 25-hydroxy-D3 in layers do you have?
Sure. Yeah, 25-hydroxy typically in layers was really fed in the laying period. And we've got some recent studies to show the great importance of it in the pullet phase. And so it's really about setting that bird up. And we really focus on the bone health of those layers to be able to set them up for productive life cycle. And we found that when it's fed in the pullets, they had that stronger cortical bone, stronger medullary bone, and it translated directly in that egg quality. So we've got some updated research on layers too.
Yeah, no, that makes sense. And to that end, so broilers, layers, and then obviously, classically we think about this being very important for breeders. I mean, do you prioritize it more for broilers or breeders, or what are your thoughts there?
Sure. Honestly, I would say both. And I say that because I wasn't able to share it today, but we've got the research in the breeders to show how impactful that can be for the progeny. Mm-hmm. So on muscle yield, on immune health as well, with that 25-hydroxy being in the breeders, how important it is for that translation into the egg and into the progeny of the chick. So we can improve that muscle yield starting from that breeder level. And for the breeders directly, the immune health that 25-hydroxy can have to keep those breeders healthy is obviously very important, and we can have an impact there as well. So both broilers and breeders for muscle yield.
The advantages to feeding the 25-hydroxy, are those increased when the breeders are fed that? So are the chicks more responsive, or are they less dependent on it if it's established in the breeders?
Sure. I'm not sure if we have a good answer to that, but my hypothesis would be that they might be more responsive to it because we've seen that increase in those VDR receptors when 25-hydroxy-D3 is fed. So if it's already present in those breeders, it's possible that the receptors in that broiler progeny might be at a higher level than they are if they weren't fed that in the breeders.
Yeah, that makes sense. I think we have one more question about, is it common for the birds to have these difficulties?
Yeah, so it's not common after that 14 days. And it's just that the enzymes, because it's a fat soluble vitamin, so A, D, E, and K, all are going to have to be absorbed using lipase bile acids to form those micelles. So if they're not as efficient as doing that. It's not that they're having a difficulty. It's just that there's a bit of an insufficiency for those first 14 days. And so that's one of the benefits of feeding a 25-hydroxy is you can bypass the insufficiencies those first couple weeks of a broiler's life.
Yeah, very good. Makes sense. Well, thanks again. Great presentation. We really appreciate the information. A lot of good comments. And so I know that the audience appreciate it. So thanks again, Shelby.
Thank you all. Thanks, Sam.